We're now moving on to electricity and magnetism. Electrostatics is the first of 5 units in our electricity and magnetism study. You already have experience with electrostatics, and what I'd like you to do right now is take a minute or two and just write down some examples that you've experienced in your life or that you know about. Once you've written down a couple of examples, write down the definition of electrostatics. It's the study of electrical charges at rest. This is a little bit of a misnomer because there is no such thing as a charge at rest, because electrostatics, the basis of it is in the atom, and it's the electrons moving around the nucleus, and those electrons are never at rest. They're always moving. The basis for the study of electrostatics is, once again, begins in the atom. You've got those electrons moving around. They have a negative charge, and the protons are in the nucleus, and they're tightly bound there, and they have a positive charge. So protons positive, electrons negative. You should already be aware from chemistry that like charges repel and opposite charges attract. The preceding ideas are derived from the study of these concepts. The fact that an electric charge is a fundamental quantity, like mass, distance, and time. Charge is observable and measurable by the force it exerts on other charges. This force is a non-contact force. In other words, the electrons don't have to be touching one another to be able to exert forces upon each other. Since they don't have to be in contact with each other, we need to have a couple of, well, not a couple, but we need one more concept or idea to be able to talk about how these forces interact over distances. And that space around the charge is defined as a field. And then within that field, we'll talk about how strong the force is at different distances away from the charges. The variable Q is used to represent the charge, and Q may be positive or negative. And the SI unit for charge is the coulomb, and it's abbreviated C. I'm normally going to write a Q like this, and its unit is a coulomb, using the letters capital C. There are 2 other terms we need to be very familiar with, and that is objects can either be insulators or conductors when you're talking about electrostatics. Conductors are substances that allow electrons to move freely. Insulators don't allow electrons to move freely. But please note, both of these objects, either conductors or insulators, have electrons. And if they have electrons, they both have protons. So you need to remember and understand that just because an object is a conductor or an insulator doesn't mean it doesn't possess charge. It's just whether or not that charge moves freely or not. The last term you need to have some concept of is the law of conservation of electric charge. And it basically says that you cannot create or destroy charge. If charge is gone from one object, it had to go someplace else. That ends the basic definitions of terms that we need to be looking at and understand. And now we're going to start looking at how do we charge objects, and specifically how do we charge neutral objects. There's 3 basic methods. There's conduction, induction, and permanent separation of charge. All 3 methods begin with separation of charge. And the idea of separation of charge is the fact that a neutral object will be attracted to a charged object. The neutral object being an object that has the same number of electrons and protons. When we come back to school, we will review the definitions. If you have any questions, have them have them ready to go, and then we'll begin looking at how do we charge a neutral object and what separation of charge really means.